Good afternoon. Yesterday we worked on CO41, learning about the theoretical probability of events. Today's objective is directly related to it. So today we're doing CO42 using experimental probability of an event. So yesterday we talked about theoretically if we flip that coin, you should get the heads 50% of the time, the tails 50%. Right? So experimentally, then we did our experiment, and what did we actually get? Okay, so your experimental probability is different than theoretical. We could say you should get it 50 coin tosses, you should get 25 heads, 25 tails, but experimentally, it is what actually happens. So instead of what should happen, it's what actually happens. Now, every once in a great while, you will have somebody say, oh, I actually got 25 heads and 25 tails. So my experimental probability matched the theoretical probability. Is that going to be the case for everyone? No. So you could experimentally get what the theoretical probability was. But the chances of that happening are pretty small, right? It is not going to happen for everyone. So let's look at our results. So you're going to have to look back at your CO41, and you're going to write in your individual results from the coin flips. How many heads did you get, and how many tails did you get? So right now, look back at your result. So Hunter, you're going to have to do this at home. You'll flip a coin 50 times and put tally marks in those boxes on CO41, and then you're going to write in your results on CO42. When we get to the class results, Hunter, we didn't include you in it because you weren't here yesterday, but you can write down what the class results are with us. So you should have your own individual numbers for heads and tails. Now, we need to figure out what the class results are. Oh boy. So we had 23 of us here yesterday. So I'm going to go through and I'm going to say, okay, for heads, I will start with Holland and I'm going to go around my tables. And we're going to write down how many heads everyone got, and then we're going to add them all up, and we're going to write that on there. So you're going to need your calculator out. And we do everybody doing the math, because sometimes one person doing it, when we have 23 numbers we're all adding up, sometimes somebody makes a mistake. But if most people get an answer for the total, then you go with what the majority gets. Elliot. Super quick. All right, so I'm going to write down the numbers for heads. And then, like I said, I'm going to go in the same order for all of these. And we'll do tails. And then when we do the dice, I'll do the ones. And then we'll do the twos and then the threes. Okay, so like I said, this is time consuming. All right, so I'm starting with Holland. How many heads did you get?
22.
Violet.
23.
Leo.
28.
Grayson.
27.
Cam.
25.
Who's after Cam? Oh,
25.
skipping Hunter, so Tochi, you'll go after Elliot.
28.
Lucas. Guys, you can just say it if you're the next person, just say it. 25.
26. 25. 21.
Say that again.
21. 25. 24.
26.
23.
Say it louder.
27. 21.
21.
20. 27.
All right, so if we add all these numbers up, What did we get? Joe, what did you get?
161.
Did everybody else get 561?
No.
Okay, what did you get, Clara?
534. Yeah.
All right, so sometimes, like I said, we make a little mistake as we're adding lots of numbers. So you said 534, Clara?
Yeah.
Okay, and we're going with majority. So 534. You don't have to write down all of these numbers if you were just plugging them into your calculator as we go. Okay, the most important part is you have the class total. All right, so now we're going to do the tails.
So 28, 27, 22, 23, 25, 21,
25.
28. Oh, 24, 25, 29, 25, 26.
24.
27. 23. 29.
29.
30. 43.
Was that 23?
Yeah.
Colton, what did you get?
572.
Is that what other people got?
Yeah.
So you said 572. So if we look back at our number, we should have, if we add both those numbers together, we should have 1,550. So 534 plus 572 is not 1,550. What is it?
That's 1,106.
Okay, so that means some people, when they were telling me their number, did we miss somebody? Did miss? Who was in here? Ashley?
No.
Ashley's in the other class. Evelyn was gone, Bo was gone, right? Wasn't Evelyn gone yesterday? Oh, is Evelyn, yeah, Evelyn's in this class. And Hunter, was it Laura?
I think when we did the count of everybody, I think you counted someone extra, because there were only 22 people, and we said 23.
Oh, because I didn't count Evelyn. I counted Evelyn yesterday and she wasn't here. I knew Bo and Hunter weren't here. So instead of 550, what should we have had? Well, then that would be 1,500, right?
We're still not even close.
Right, so 1, 2, 3, 4, 5, 6, 7, 8, 20. I only have 22 numbers on here. Who didn't tell me their tails? So, okay, Holland, did you have 28 tails?
Yes.
Violet, Leo, you were at 22. Grayson, 25, 25? Yep. 28? 25? Grace, 28?
Yep.
24, 25, 29, 25, Ellen, 26?
Yep.
24, 27?
Yep.
27, 23, 29,
29, 22.
23? Okay, so I got all of our numbers. I don't know where we're going wrong here.
Someone probably put their coins away.
Yeah, we might have had some people counting numbers.
Because someone had 30.
Add up your numbers.
Add up these numbers again?
Add up like the amount of coins you
Sure.
put. Because I think some people probably flipped either too many or something.
Yeah, if you had 25 and 25, we know you had 50.
Gambino,
Yeah.
is the calculation to see how much, is it?
Oh, I wrote down 1,500, it's not 1,500, 1,100.
Yeah.
That's where we, okay. It was, and we had to take 50 off because Evelyn
Oh,
wasn't
yeah.
here. So 1,100. That was our total number of flips. Okay, so total number of flips was 1,100. Heads, we had 534. So theoretically, we had said 1,100 would be, what, 650? 550. And 550 for heads and tails, because we had to take 25 and 25 off. Clara?
When I add 534 plus 572, we get 1,106.
So there was a few people that were a little off on their count. Being off by 6 is a whole lot better than being off by the 400 I thought we were off. Okay, so this makes more sense to me. So, yep, it makes sense that somebody accidentally flipped it 31 or 32 times. We had a little oops on our counting. Okay, that makes sense. So we're close, okay? So what we ended with was 1,106 instead of 1,100. Okay, so theoretically, we had said there'd be 1,100. We got 1,106. So compare your class results. Which was closer to the theoretical probability? If we thought it would be 534, theoretically it was 500, or sorry, actually it was 534, theoretically it was 550. Oh, what's closer? Individual or class? So if you individually had 29 heads and 21 tails, thinking about probability-wise, what's closer? How do we figure that out? How do we figure out your probability with which is closer? Had the experimental or your theoretical?
You divide them by the
So 29 divided by 50, what was that? What's 29 divided by 50?
0.85 or 0.58.
58. Okay, so if you had 29 heads, that would be 0.58. How do we figure it out with the whole class? So that would be 534 over, let's go with what we actually had, 1,106. What's 534 divided by 1,106? Colin?
0.48.
And theoretically, it should have been 50%, right? 50% times of getting heads, 50% times the tails. Which one is closer to 50%? 48% or 58%?
48.
The 48. So depending on what you actually flipped versus what the whole class flipped, sometimes if you have the bigger difference, the class is going to be closer to theoretical probability. If you were one of those lucky few who actually did 25 and 25, what's going to be closer, your individual results or the class results? The individual results. How many of us were closer to that 50% than the 48%? Raise your hand. If you were closer to 50% with your individual results than what the class had. Raise it up high so you can count. So 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 23 people had their individual results closer to the theoretical probability than what the class did. So the class in general was closer to theoretical probability. Yes, we have some people who got lucky, but the majority was off more individually than the class. Does that make sense? So some of us got lucky, but most of us were not closer to that theoretical probability. Let's look at it with the dice. So, log in what your results were for your dice rolls. 1s, 2s, 3s, 4s, 5s, and 6s. How many did you roll? We have to change theoretically what the class should get. Because I accidentally had Evelyn on there. So the class should have gotten 2,640 total rolls. So each individual one.
It already says 20.
No, for each number
Oh.
should be 420. So we know with the coin flips, it should have been 25 and 25. We're gonna see how close we are to that 420 for each of our number rolls when we add them all up. Total amount should be 2,640. Okay, so we're gonna go through. Does everybody have their numbers logged in? So just like with our heads and tails, we're gonna go in that same order. So pay attention when it's your turn to say your number. Okay, we're gonna start with ones. You're gonna tell me, how many times did you roll a 1? And you're gonna add them up as I write them down. Laura?
I think the theoretical total is 440.
Oh, I subtracted 40 instead of 20. Thank you. That's what happens when I try to do it off the top of my head and I'm a little frustrated. Thank you for checking that. All right, so ready for the one, same order. Holland,
25. 20.
Leo,
22. 22. 19. 22.
23.
15. 30. 14. 18. 25. 22.
19.
21. 17. 19.
23.
18. 17.
Did you say 19?
Yeah.
All right. What'd you get, Elliot?
441.
441?
Yeah.
Yeah? Okay, so 441 for our ones. Twos, Holland.
19. 15. 18. 26. 14. 19. 21.
24.
20. 15. 21. 23. 20.
21.
Hold up, Ellen, you said 20?
Mhm.
Okay, Henry's 21.
20. 22. 17. 19. 18. 20.
Did I get it? What are you, Victoria?
20.
So both you and Finley had 20, right?
No, the 120 was hers.
Okay, oh, that sounded like Finley's voice.
18.
Okay. 120 at the top. Clara,
434.
434, is that what everybody else got?
442. Yeah, that's what I got.
442?
Yeah.
Okay. It's easy to make simple mistakes, so that's why we double check and have multiple people doing the adding. All right, threes. Holland,
12. 26. 21.
14.
25,
20.
16, 25, 18, 21, 13, 16,
21.
18, 25,
24.
16,
21.
19, 19,
Alan?
437,
Joe?
394.
Gavin?
410,
Finley?
437,
What did you get, Lucas?
437.
How many of you got 437? Okay, most of us got that. All right, fours, Alan.
20, 18, 21,
18.
18, 18, 18,
16.
29, 15, 27, 19, 20, 19,
17.
21, 13,
13.
20,
17.
27, 21,
Finley?
424,
424?
425.
425? Okay.
I got 466.
You're adding a number twice probably. All right, fives, Holland.
25, 17, 17, 22, 22, 21, 22,
22.
14, 27, 21, 15, 21,
22.
20, 22,
23.
23,
22.
13, 20,
Joe?
429,
429?
456,
No, I think it's more than that.
Golden?
441.
Gavin?
451.
Yeah.
Yeah.
How many of you got 451?
Dang it.
Okay, we'll go with 451, that's the majority. Last one, sixes, Holland.
19,
Sorry.
19,
19.
24, 21, 18, 25, 19, 22,
15.
21, 16, 19, 20, 24, 22,
20.
20, 23,
21.
25,
18.
28, 21, 452.
452.
Oh,
Now, we need to, just like we did with our heads and tails, look at what your probability was for the ones, twos, threes, fours, fives, sixes. Each individual one, look at the class, theoretical results of each. So up top, theoretical results was 20. So were you closer to the theoretical probability with your experimental? Then for the class, it should be 440. Our total amount, do it out of that 2,640. Clara,
2,650.
is that what these 5 all, or 6 all added
Yeah.
to? All right, so instead of 40, we're gonna change that to the 50. 2,650?
Yeah.
Okay. Okay, so that's our total amount. Some people rolled a little incorrectly, it happens. All right, so figure out your individual, then figure out the class. What was the probability for each number? Which one overall was closer? You might have gotten a 20 for one of the numbers, but for all 6 numbers, were you closer to that theoretical, or was the class closer to the theoretical? So right now, figure out your math for your results.
What was the number again?
2,650 was the total amount for the class. So figure out the class theoretically, what percentage for each roll. Figure out your own individual, just like we did with the heads and tails. And then look to see which was closer, individually or the class. So, no, for 440 is the theoretical results, just like 20 was that theoretical result. So you're doing the experimental. 441 divided by 2,650. 442 divided by 2,650 for the class results. So everybody's going to get the same for the class results. You're figuring out for your individual results, what was your, so if you had 19 out of 20, what is that? If you had 13 out of 20, what is 13 divided by 20? So figure out your own individual. Somebody figure out the class and tell me what you got for the class so I can write those up there. Because I don't have my calculator over here and too big of math for me to do in my head right now. Claire, did you do the class ones?
No,
Or-
this is just a question. Is it supposed to be closer to 100% or 50%? Your number, your individual numbers.
So, what's 404, well, here, it would be, you would want 20 out of 20, so 100%. So, what's 441 divided by 2,650?
100.
441 divided by 2,650. And I was wrong, it's not 20 out of 20, it would be 20 out of 120, because you had 120 rolls. So the total rolls up here, if you had 19, you do 19 divided by 120. I said that wrong, so that was my mistake.
I didn't think it wasn't, and I got 2,658. Yeah, that's correct.
2,600 what?
Yeah.
Is that what everybody else got?
Yeah.
Okay, so our total amount, 2,648. So, individually, take your number, divide it by 120. For the class, take the number divided by 2,648. When you get the class results for the 1s, 2s, 3s, 4s, somebody tell me what you got, because I don't have a calculator over on this side. Individual, you're dividing by 120, so you had 120 rolls. For the class, you're dividing it by 2,648. So are you actually doing the math there, Mr. Leo? Because you're kind of staring off. So I did the class ones. We had 17%, 17%, 17%, 16%, 17%, and 17%. Look at your individuals. So if you had, let's say, I saw some that were like 14, right? So 14 divided by 120, that would be 12%. So was your individual closer or was the class? Because if we had 440 divided by 2648, that was, theoretically, we should be at an 18%. So which one's closer? 12% or 17%? The class is closer, right? What's somebody's percent that you got for the twos? Ellen?
0.16.
What's closer to that 18? The 0.16 or the 0.17? The 17 is closer to that 18%. What's a threes, what percentage somebody got? Finley?
16.
Again, 0.16 to 0.17, which one's closer to the 18? The class. Are we noticing the pattern? Fours. Claire, what'd you get?
0.18.
Clara's is closer. How many of you got 18% for the fours? Raise your hand. You should raise your hand. So I have 4 of you that actually got the theoretical probability. 18 of you did not. Right? So 18 of us, they weren't, the class was closer.
Wait,
Yeah.
I got 18, not 18%.
Right, 0.18 is 18%.
No, I got 18 as the answer.
Oh, I see what you're saying. So, which one more likely is going to be closer to that theoretical probability? Your individual or the whole class? What have we been finding? What's closer to that theoretical probability? Your individual results or the whole entire class results?
The class.
The class results. This leads us to the law of large numbers. The law of large numbers says the more times you do something, the closer experimental probability gets to theoretical probability. This is why when people go to casinos, they get in trouble. They get lucky a couple of times. The more times you do something, the closer you're going to get to theoretical probability. What is the theoretical probability for casinos? Who's going to win? The house. The house always wins. Ooh, you might get lucky and win a couple of times. But the odds are against you. Probability-wise, the more times you do it, the closer you're gonna get to losing and the house winning. Right? So if you get really lucky at a casino, take your winnings and walk away. Right? Because the more times you do it, the more times you're going to fail and you're going to lose. We are going to talk about these tomorrow, but we do need to know that law of large numbers. That is huge. We'll talk more about that tomorrow. If you are watching this at home, I hope you are well and I hope to see you soon. Have a wonderful day.